Hey everyone, it's Marquet here. Today we're diving into the top challenges that software developers face in their daily professional life. From technical hurdles to personal well-being, let's break it down. Being a developer is often portrayed as this super sleek, almost futuristic job, and in many ways it is. You're building the tools, the apps, the platforms that shape how we interact with the world. But behind those clean lines of code and smooth user interfaces, there's a whole world of complexities, frustrations, and unique pressures that aren't always visible from the outside. We're not just talking about finding that one missing semicolon that's been haunting you for hours, though that's definitely part of it. We're going deeper into the systemic issues, the communication breakdowns, the constant learning curve, and even the mental game that developers have to navigate. Think of it like this. Every app you use, every website you visit, is the result of a team of developers overcoming a series of these challenges. It's a demanding field, but also an incredibly rewarding one. So in this video, we're going to pull back the curtain and really explore what it means to tackle these obstacles day in and day out. Whether you're an aspiring developer, a seasoned pro, or just curious about what goes on in the tech world, I think you'll find this insightful. We'll cover everything from dealing with ancient, cryptic code bases to managing unrealistic expectations and the ever-present imposter syndrome. Alright, enough preamble, let's get into it. Alright, first up, let's talk about something every single developer, no matter how experienced, grapples with: debugging complex issues. This is the quintessential developer headache. You've written your code, it looks good at work, but then it doesn't. And the error message is either non-existent or so cryptic it might as well be written in an ancient alien language. The frustration here is palpable. You start questioning your skills, your sanity, even the very laws of computing. It's a detective story where you're both the investigator and, sometimes, inadvertently, the one who created the mystery. One of the most infuriating aspects of debugging is dealing with bugs that are incredibly hard to reproduce. You know, the ones that only seem to appear on a Tuesday when the moon is in a specific phase and the user is holding their phone upside down. These Heisenbugs can feel like they're actively taunting you. You try to replicate the reported conditions, step through the code meticulously, but everything works perfectly on your machine. This can lead to long, drawn-out investigations, trying to gather more information from users or setting up elaborate logging systems just to catch a fleeting glimpse of the problem in its natural habitat. Then there's the lovely experience of tracing through poorly documented legacy code. Imagine being an archaeologist, but instead of ancient ruins, you're sifting through layers of code written years, sometimes decades ago, by developers who have long since moved on. There are no comments, or worse, misleading comments. Variable names are obscure, logic is convoluted, and every change you consider feels like defusing a bomb. One wrong move and the whole system could come crashing down. This isn't just time-consuming, it's mentally draining, requiring immense patience and a knack for reverse engineering. The process of debugging, especially in these complex scenarios, can consume vast amounts of time. What might seem like a small issue on the surface can unravel into days of painstaking work. You're setting breakpoints, printing out variable states, reading through stack traces, and trying different hypotheses. It's a methodical process, but when you're under pressure to deliver, every hour spent debugging feels like an hour not spent building new features or improving the product. This constant battle against the unexpected is a core part of a developer's life, and it requires a unique blend of persistence and problem-solving skills. Ultimately, finding and fixing that elusive bug can be incredibly satisfying. There's a real sense of triumph when you finally understand what went wrong and implement a clean solution. But the journey there can be a roller coaster of frustration, self-doubt, and sheer bewilderment. It's a reminder that software development is as much an art of troubleshooting and patience as it is an art of creation. Learning to manage this frustration and develop effective debugging strategies is crucial for long-term survival and success in this field. Next on our list of developer challenges is dealing with legacy code. Now, legacy can be a bit of a loaded term in tech. It doesn't necessarily mean bad code, but it often refers to code that's old, built with outdated technologies, and potentially lacking in modern best practices or documentation. Stepping into a project dominated by legacy code can feel like inheriting an old, sprawling mansion. It might have character and a solid foundation, but it also has creaky floors, leaky pipes, and a wiring system that no one fully understands anymore. One of the primary challenges here is working with outdated frameworks and libraries. Technology moves at lightning speed, and a framework that was cutting edge 5 or 10 years ago might now be unsupported, have known security vulnerabilities, or simply lack the features and performance of its modern counterparts. Developers tasked with maintaining or extending these systems often find themselves constrained by these old tools. They can't easily integrate new technologies, and finding resources or community support for these older systems becomes increasingly difficult over time, turning simple tasks into complex research projects. Then there's the ever-present fear of breaking existing functionality when making updates. Legacy systems, especially large and complex ones, often have intricate dependencies and undocumented behaviors. A seemingly small change in one part of the codebase can have unforeseen ripple effects, causing critical features to fail in unexpected ways. This fear factor can lead to a very cautious, sometimes overly hesitant, development approach. Developers might avoid necessary refactoring or improvements simply because the risk of introducing new bugs feels too high, leading to a slow accrual of technical debt. The lack of documentation or outdated documentation is another huge hurdle. When you're trying to understand a piece of legacy code that has no comments, no design documents, and no original developers around to ask, you're essentially reverse engineering its purpose and behavior from scratch. This is incredibly time-consuming and error-prone. You're piecing together clues, making educated guesses, and hoping you're not misinterpreting the original intent. It's like trying to assemble a complex puzzle without the picture on the box, and some pieces might be missing entirely. Ultimately, working with legacy code requires a specific mindset. It demands patience, meticulous attention to detail, and a willingness to dive deep into unfamiliar territory. While it can be frustrating, there's also a certain satisfaction in successfully modernizing parts of an old system, improving its stability, or extending its lifespan. However, the constant tension between maintaining the old and integrating the new, all while trying not to break anything, makes legacy code a persistent and significant challenge for many developers throughout their careers. Alright, let's shift gears to another constant in a developer's life: keeping up with changing technology. The tech landscape is not just evolving, it's in a perpetual state of hyper-evolution. New programming languages gain traction, frameworks get updated or replaced, tools become more sophisticated, and entirely new paradigms emerge. What was best practice last year might be outdated this year. This relentless pace of change means that learning isn't just something you do at the beginning of your career. It's a continuous, lifelong commitment. The sheer volume of updates can be overwhelming. Every week it seems there's a new JavaScript framework, a new version of a popular back-end language, a new cloud service, or a groundbreaking AI model that promises to revolutionize development. Developers are constantly bombarded with information about these new tools and technologies through blogs, newsletters, conferences, and social media. Deciding what to focus on, what's genuinely a game changer versus what's just a passing fad, becomes a challenge in itself. It's like trying to drink from a fire hose. This constant need to learn creates significant pressure to quickly absorb and apply new knowledge. It's not enough to just read about a new technology. You often need to get hands-on with it, build small projects, and understand its nuances to be effective. This learning often has to happen on your own time, outside of regular work hours, especially if your current projects don't immediately require these new skills. This can eat into personal time and contribute to feelings of always being on or needing to catch up. Moreover, the half-life of technical skills can feel alarmingly short. The tools and techniques you master today might become less relevant in a few years. This necessitates a proactive approach to skill development. Developers need to be strategic about their learning paths, anticipating future trends and investing time in acquiring skills that will keep them marketable and effective. It's a bit like being an athlete who constantly needs to train and adapt their techniques to stay competitive at the highest level. While this constant learning can be exciting and intellectually stimulating for many, it's also a source of stress and potential burnout. The feeling that you're always behind or not learning fast enough can be taxing. However, embracing this as part of the job, fostering a genuine curiosity and finding efficient ways to learn are key. Successful developers often build a habit of continuous learning, integrating it into their routine and finding joy in discovering new ways to solve problems and build better software. Chapter 4: Bridging the Gap Tech Talk for Everyone. Now let's talk about a challenge that steps outside the code itself, but is just as critical. Miscommunication with non-technical stakeholders. Developers often work closely with product managers, designers, clients, or marketing teams who may not have a deep understanding of the technical intricacies involved in building software. Bridging this communication gap is a constant and often delicate task. It's not just about what you say but how you say it, ensuring clarity without oversimplifying to the point of being misleading. One of the biggest struggles is conveying complex technical concepts in simple, understandable terms. Explaining why a seemingly small feature request might take weeks to implement, or why a particular technical constraint exists, can be incredibly difficult. Developers might use jargon or delve into details that, while accurate, only serve to confuse the non-technical person. Finding the right analogies, focusing on the why behind technical decisions, and understanding the stakeholder's perspective are crucial skills that aren't always taught in coding boot camps. This communication challenge often leads to dealing with unrealistic expectations from product managers or clients. If stakeholders don't understand the effort involved, they might set aggressive timelines or expect features that are technically infeasible within the given constraints. Saying no, or that's much harder than it looks, can be difficult, especially when you want to be seen as a can-do problem solver. It requires tact, clear justification, and sometimes a willingness to educate stakeholders on the realities of software development. The consequences of miscommunication can be severe. It can lead to wasted effort building the wrong thing, frustration on both sides, and a breakdown of trust between the development team and other parts of the organization. When requirements are misunderstood, or technical limitations aren't properly communicated, the end product often suffers. Developers might build a feature that doesn't meet the actual business need, or stakeholders might be disappointed when the delivered product doesn't match their, perhaps technically uninformed vision. Effective communication is therefore a soft skill that is incredibly valuable for developers. Learning to listen actively, ask clarifying questions, present technical information in multiple ways, and empathize with non-technical perspectives can significantly improve collaboration and project outcomes. It's about being a translator, an educator, and a partner in achieving shared goals, rather than just an order taker who writes code in isolation. This is a skill that often develops with experience and conscious effort. Chapter 5. Moving targets. When project scope shifts. Another classic challenge that can drive developers up the wall is dealing with unclear or changing requirements. You start a project with a specific set of goals and features in mind, you meticulously plan your approach, and then midway through development, the goalposts shift. This phenomenon, often called scope creep, is a major source of frustration and inefficiency in software development. It's like trying to build a house while the architect keeps changing the blueprints. The problem often begins with requirements that are vague, ambiguous, or incomplete from the outset. If the vision for the product isn't clearly defined and documented, developers are left to make assumptions or fill in the blanks. This can lead to building features that aren't quite what the stakeholders envisioned, necessitating rework later on. The time spent trying to clarify these ambiguities up front is almost always worth it, but often the pressure to start coding means this crucial step is rushed or skipped. Then there's the issue of shifting goals mid-development. Market conditions change, new competitor features emerge, or internal priorities get reshuffled. While some adaptability is necessary, constant and significant changes to requirements can be demoralizing for a development team. They might have invested considerable effort in building a feature based on the original specifications, only to be told it's no longer needed or needs to be drastically altered. This can make developers feel like their work is undervalued or that they're constantly chasing a moving target. The frustration is compounded when features that have been painstakingly built get scrapped entirely due to misalignment or a change in strategy. Imagine spending weeks or even months crafting a complex piece of functionality only for it to be shelved before it ever sees the light of day. This isn't just a waste of development resources, it's a blow to morale. It can lead to a sense of cynicism and a reluctance to fully invest in new features if there's a perception that they might also be abandoned. Effectively managing requirements and scope is a collaborative effort that involves product owners, project managers, and the development team. Clear communication, robust change control processes, and a shared understanding of the project's core objectives are essential. For developers, this means learning to ask probing questions, pushing back constructively when scope creep becomes unmanageable, and advocating for a development process that allows for some flexibility without derailing progress entirely. it's a delicate balance between agility and stability. Chapter 6. Team Synergy, Making Collaboration Work. Software development is rarely a solo endeavor, it's usually a team sport. And like any team, the dynamics within a software development team can present their own unique set of challenges. Navigating these interpersonal and collaborative aspects is crucial for a productive and positive work environment. It's not just about individual coding skills, it's about how those skills combine and interact within the group. One common challenge is working with team members of varying skill levels and personalities. A team might consist of junior developers who need mentorship, senior developers with strong opinions, and individuals with different communication styles or work habits. Integrating these diverse individuals into a cohesive unit requires patience, empathy, and strong leadership. Misunderstandings can arise and differences in approach can sometimes lead to friction if not managed constructively. Code reviews, while essential for maintaining code quality and sharing knowledge, can sometimes be a source of tension. Giving and receiving feedback on something as personal as code requires a certain level of tact and humility. Reviews that are overly critical, nitpicky, or delivered without constructive intent can demotivate developers. Conversely, reviews that are too superficial can let quality issues slip through. Finding the right balance and fostering a culture of respectful, helpful feedback is key. Pair programming, another collaborative practice, comes with its own set of challenges. While it can be great for knowledge sharing and complex problem solving, it also requires strong communication and compatibility between partners. Differences in coding speed, problem-solving approaches, or even just personal energy levels can make pairing an unproductive or uncomfortable experience if not handled well. It demands a high degree of synchronicity and mutual respect. Architectural disagreements are also common. Developers, especially experienced ones, often have strong, well-reasoned opinions about the best way to design a system, choose a technology stack, or structure a particular piece of code. These discussions can be healthy and lead to better outcomes, but they can also devolve into lengthy debates or stalemates if there isn't a clear process for decision-making or a willingness to compromise. Navigating these technical debates professionally and ensuring everyone feels heard is vital for team cohesion. Let's talk about something that can cast a long shadow over a developer's work life: unrealistic deadlines. The pressure to deliver software under tight timelines is a pervasive challenge in the industry. Business needs, market opportunities, or competitive pressures often translate into aggressive schedules, and developers are frequently caught in the middle, trying to meet these demands without sacrificing the quality of their work or their own well-being. The core issue often stems from a disconnect between the perceived complexity of a task and the actual effort required. Non-technical stakeholders might underestimate the work involved in building robust, well-tested software. This can lead to deadlines being set that are ambitious at best and completely unachievable at worst. Developers then face the unenviable choice of pushing back, which can be difficult, or attempting to meet the deadline by cutting corners or working excessive hours. This pressure to deliver quickly can directly impact code quality. When time is short, thorough testing might be curtailed, documentation might be skipped, and shortcuts might be taken in the code itself, leading to technical debt that will need to be addressed later. While shipping quickly can have short-term benefits, the long-term costs of poor quality, more bugs, harder maintenance, and slower future development can be substantial. It's a classic trade-off that developers constantly navigate. Frequent crunch time is another unfortunate consequence of unrealistic deadlines. While occasional periods of intense work might be unavoidable, a culture where crunch is the norm is unsustainable and detrimental to developer health. Long hours, working weekends, and constant high-pressure situations lead to burnout, reduced creativity, and an increased likelihood of mistakes. Burnout isn't just bad for individual developers, it's bad for team productivity and retention in the long run. Effectively managing deadlines requires realistic planning, clear communication about scope and effort, and a willingness from all stakeholders to prioritize. For developers, it means getting better at estimation, clearly articulating the trade-offs between speed and quality, and advocating for sustainable work practices. It's about finding a balance where ambitious goals can be pursued without consistently pushing teams past their breaking point, ensuring that the marathon of software development doesn't turn into a series of exhausting sprints. Another significant daily challenge for developers is task prioritization. In any given workday, a developer might be faced with a long list of potential tasks, urgent bug fixes that are impacting users, new feature development that's critical for the next release, long-term refactoring goals to improve code health, requests from colleagues for help or code reviews, and various administrative duties. Deciding what to work on first and how to allocate limited time effectively can be a constant struggle. One of the classic dilemmas is balancing urgent bug fixes with important but less immediately visible long-term refactoring goals. Production bugs often demand immediate attention, pulling developers away from planned work. While fixing these is crucial, consistently deprioritizing refactoring and technical debt reduction can lead to a codebase that becomes increasingly difficult and slow to work with over time. It's a balancing act between firefighting immediate problems and investing in future stability and efficiency. Juggling multiple tickets or projects simultaneously is another common scenario. A developer might be assigned to several active Jira tickets, each with its own priority and deadline, or they might be contributing to different features or even different products concurrently. Switching between these different contexts, keeping track of progress on each and ensuring that none of them fall through the cracks requires excellent organizational skills and mental discipline. It's easy to feel spread too thin. The pressure to prioritize can also come from various stakeholders, each advocating for their own requests. The support team might be pushing for a critical bug fix, the product manager for a new feature, and a fellow developer for help with a blocker. Learning to navigate these competing demands, communicate capacity limitations, and make informed decisions about what to tackle next is a key skill. Sometimes this involves saying not right now or negotiating timelines, which isn't always easy. Ultimately, effective task prioritization is about maximizing impact and making conscious choices about where to focus energy. Tools like to-do lists, Kanban boards, and time-blocking techniques can help, but so can clear communication with team leads and product owners about priorities and workload. Developers who master this skill are not only more productive, but also experience less stress from feeling overwhelmed by an endless stream of tasks. It's about working smarter, not just harder, on the things that truly matter. Context switching. This is a subtle but incredibly potent productivity killer for software developers. Imagine being deep in concentration, holding a complex mental model of a particular piece of code in your head, and then suddenly being pulled away to answer a quick question, attend an unplanned meeting, or look into an unrelated urgent issue. That intricate mental model shatters, and getting back into that focused state, that flow, can take a significant amount of time and effort. The productivity loss from frequently jumping between different codebases, tools, or even different teams can be immense. Each system has its own logic, its own conventions, its own set of problems you're trying to solve. When you switch, you have to mentally unload the context of the previous task and load up the new one. This isn't instantaneous. It's a cognitive process that consumes energy and time. The more frequently you switch, the more time is spent in this reorientation phase rather than in actual productive work. Frequent interruptions are a major culprit. A quick Slack message, an email notification, a tap on the shoulder. Each one can derail a train of thought that might have taken minutes or even hours to build up. While collaboration is important, an environment with constant interruptions makes it incredibly difficult for developers to achieve the deep focus required for complex problem-solving and coding. It's like trying to read a complicated book while someone keeps randomly changing the page. Meetings, especially if they are numerous, poorly planned, or not directly relevant, also contribute significantly to context switching. A developer might have a productive morning coding session planned, only to have it fragmented by multiple meetings. Each meeting requires a mental shift away from coding tasks, and then another shift back afterwards. If meetings are too frequent, a developer's day can feel like a series of short, unproductive bursts of coding sandwiched between context switching overhead. Minimizing unnecessary context switching is key to developer productivity and well-being. This can involve strategies like blocking out focus time on calendars, turning off notifications when deep work is required, encouraging asynchronous communication for non-urgent matters, and ensuring meetings are well organized and truly necessary. For developers, cultivating the ability to quickly refocus can help, but systemic changes to reduce the frequency of context switches often yield the biggest benefits for the entire team. Chapter 10. The Creative Wall Overcoming Developer's Block. Every developer, no matter how brilliant, eventually hits a mental block. This is that frustrating experience of spending hours, sometimes even days, stuck on a problem that, in hindsight, might seem relatively simple. Your brain just refuses to see the solution. You try different approaches, you stare at the same lines of code until they blur, but progress grinds to a halt. It's like your mind has built a wall, and you can't seem to find a way over, under, or around it. This frustration can be particularly acute when you're up against a deadline, or when the problem feels like something you'd be able to solve quickly. It can lead to feelings of inadequacy and self-doubt. You might start questioning your abilities, wondering if you're cut out for this kind of work. The more you try to force a solution, the more elusive it can become, leading to a downward spiral of frustration and reduced cognitive performance. Creative fatigue from continuous problem-solving is another facet of this challenge. Software development is an intensely creative and mentally demanding activity. You're constantly designing, building, and debugging complex systems. Over time, especially during periods of high pressure or long hours, your mental reserves can get depleted. Ideas don't flow as easily, your focus wanes, and even routine tasks can feel more challenging. It's the cognitive equivalent of an athlete hitting their physical limits. One of the most effective yet often counterintuitive ways to overcome a mental block is to step away from the problem. Take a walk, work on a different task, talk to a colleague, or even just get a good night's sleep. Giving your subconscious mind time to work on the problem in the background, or approaching it with a fresh perspective later, can often lead to a breakthrough. The aha moment frequently strikes when you're not actively trying to force it. Learning to recognize the signs of a mental block and having strategies to deal with it is an important part of a developer's toolkit. This might include techniques like rubber duck debugging, explaining the problem to an inanimate object, breaking the problem down into smaller pieces, or seeking help from peers. It's a reminder that problem-solving isn't always a linear process, and that sometimes the most productive thing you can do is to give your brain a rest and a chance to reset. Chapter 11. The Confidence Conundrum Battling Imposter Syndrome. Let's delve into a more personal yet incredibly common challenge for developers' imposter syndrome. This is that persistent internal feeling of inadequacy, the nagging doubt that you're not as skilled or competent as others perceive you to be, despite evidence of your accomplishments. It's the fear of being found out as a fraud, even when you're objectively doing well in your role. This feeling can affect anyone, from junior developers just starting out to seasoned veterans with years of experience. Imposter syndrome often manifests as a tendency to downplay achievements, attributing success to luck or external factors, rather than your own abilities. You might find it hard to accept compliments or feel like you don't truly deserve your position, or the recognition you receive. This internal narrative can be incredibly damaging, eroding confidence and leading to anxiety and stress, even when, from an outside perspective, you are performing exceptionally well. A common trigger for imposter syndrome in the tech world is the tendency to compare oneself to more experienced or seemingly more knowledgeable developers. In a field that's constantly evolving and where there's always something new to learn, it's easy to look at others who seem to grasp complex concepts effortlessly, or who have expertise in areas you don't, and feel like you're falling short. Social media and public forums, where people often showcase their successes, can sometimes exacerbate these feelings. The fast-paced nature of technology and the vastness of the field can also contribute. No single person can know everything about software development. There will always be new languages, frameworks, and tools to learn. This can create a persistent feeling of not knowing enough, which imposter syndrome can latch onto. It can make developers hesitant to ask questions for fear of appearing ignorant, or reluctant to take on new challenges for fear of failure. Overcoming imposter syndrome is an ongoing process. It involves recognizing these feelings for what they are, often unfounded anxieties rather than objective assessments of your skills. Talking about it with trusted colleagues or mentors can help, as you'll often find that many others share similar experiences. Focusing on your growth and learning, celebrating small wins, and reminding yourself of your past successes can also help to build a more resilient and accurate self-perception. It's about learning to trust in your abilities and acknowledge your value. Chapter 12. Leadership Lapses, When Planning Goes Awry. Finally, let's address a challenge that can significantly impact a developer's productivity and morale: poor management or planning. While developers are responsible for writing code, the environment and direction provided by leadership play a crucial role in their ability to do so effectively. When there's a lack of clear leadership or technical direction, teams can flounder, projects can lose momentum, and frustration can build. One major issue is the lack of clear technical vision or strategy. If developers don't understand the why behind what they're building, or if the technical roadmap is constantly shifting without clear justification, it's difficult to stay motivated and make informed decisions. They might feel like they're working on features that don't align with broader goals, or that their efforts are being misdirected. Clear, consistent communication from leadership about objectives and priorities is paramount. Poorly defined project requirements or a lack of detailed planning can also be a significant source of trouble. If tasks are ambiguous, or if dependencies aren't properly identified upfront, developers can spend a lot of time seeking clarification, redoing work, or dealing with unexpected roadblocks. Effective project management, which includes breaking down large tasks, defining acceptance criteria, and facilitating clear communication, is essential for smooth execution. Without it, chaos can easily ensue. Excessive or unproductive meetings are another common complaint related to poor management. While meetings are necessary for coordination and decision-making, too many meetings or meetings without clear agendas and actionable outcomes can severely cut into a developer's focus time. Developers need large, uninterrupted blocks of time for deep work. A calendar packed with back-to-back meetings leaves little room for the concentration required to write quality code, leading to frustration and reduced output. Micromanagement, or conversely, a complete lack of support and guidance, can also be problematic. Developers need autonomy to solve problems creatively, but they also need support when they encounter obstacles or require decisions that are beyond their scope. Finding the right balance of oversight and empowerment is a hallmark of good technical leadership. When this balance is off, it can stifle innovation, create bottlenecks, or leave developers feeling adrift and unsupported. Addressing these management and planning issues is key to fostering a productive and healthy development environment. Awry wrapping up the developer's journey. So there you have it, folks. These are some of the most common challenges that software developers face. As you can see, it's a multifaceted profession that goes far beyond just typing code into an editor. It involves intricate problem-solving, continuous learning, effective communication, strong teamwork, and a good deal of mental resilience. From wrestling with stubborn bugs and navigating complex legacy systems, to managing stakeholder expectations and battling imposter syndrome, the daily life of a developer is rarely dull. Each of these challenges, while sometimes frustrating, also presents an opportunity for growth. Overcoming a difficult bug builds debugging skills. Successfully refactoring legacy code deepens your understanding of software architecture. Learning to communicate technical ideas clearly makes you a more valuable team member. It's through tackling these hurdles that developers hone their craft, build resilience, and ultimately create the amazing technology that powers our world. It's a journey of constant learning and adaptation. Remember, it's important to take breaks, stay focused, and prioritize your mental health. The demands can be high, but recognizing these challenges and developing strategies to cope with them is key to a long and fulfilling career in software development. Hopefully, this gave you a better insight into the DV life. Thanks for watching, and don't forget to like and subscribe for more content.